Hello and good evening. My name is Brigu Kapoor and my project partners are Upasna Banerjee and Ashray Agarwal. It's unfortunate, but they have viral fever and won't be joining us for this presentation right now. Nevertheless, we're going to continue without them and they're going to be there for the next round of presentation that is going to be about the demo of the project and what we actually achieved once we finished implementing our project. So let's dive into what our project actually is. It is about a smart garbage management system which is designed for smart cities, and we're honored to receive the guidance of our professor Dr. M. Rajashekhara Babu for the implementation of this project. So here is what we're going to show, what we're going to do with this project. Here is a basic outline of how our project, of how this presentation will function. First, we're going to tell you about the importance of this area. Second, describe what the problem statement is and what is the need for this project in the world that we live in. Third, what do we achieve out of this project, or what do we intend to achieve out of this project. We're going to show you then a feasibility analysis of why we think that this project or the way we are implementing it is feasible for the stakeholders of this project. Fifth, about what is the scope of this project and what is the end goals. Then we're going to talk about functional requirements, non-functional requirements, and then actually show you a model of what our proposed model is and how we're going to implement it. Then we're going to talk to you about software requirements and hardware requirements for our project. Right, so let's continue. Right, so just a general introduction, why we need this project and what is the need, right? In developing countries, there is a lot of problem with garbage. Garbage is known to create A, bad smell, B, like it is unpleasant to look at, and thirdly also is the breeding ground of mosquitoes, which breed and spread diseases in our society. That means that most of the brunt of this is faced by developing countries where there isn't proper sanitation techniques, or where techniques aren't modernized enough, or where they do not use things like advanced technology such as GPS to ensure that garbage collection is done in an efficient manner. This could be prohibitive because of a couple of reasons. Firstly, because of the exorbitant cost of developing and making a system that ensures that proper cleanups are done. Secondly, because the trips of the garbage trucks are limited by the ability or the funding that garbage companies get in the first place from governments. And thirdly, the reluctance of countries to ever spend in modernizing a project or a field where they see no scope in. We think that we can change it on our side, and we'll try to show you how we do it with the minimum possible resources that we can use, right? So also the existing method that we have relies too much on human prediction, B, on following conventional routes which can turn, or which may not seem the most optimized and the best possible routes to follow. Why? Because then you can have a system where you go through a route once which covers, say, a market, a residential area, commercial districts, but certain areas require more amount of garbage collection than the other. That is to say, a market will produce more garbage than a residential area, and the pickup should be scheduled more than once at that location rather than once at that place. And that should be the first priority where you pick up garbage, because a lot of people are visiting that area and a lot of people are going to carry diseases if it spreads from that area. Hence, that should be the first priority. All these things will be taken into account by our project once we implement a model in which we're going to link garbage trucks and moreover garbage cans to a GPS system, which ensures and tells you about how much garbage is there in the can and which place needs to have a pickup immediately, right? So let's move on to the next item. Right, what is the problem statement? The problem statement is to implement a system that tracks garbage cans, maps it with Google Maps, and also detects the amount of waste present in it. I've talked to you about at length of why there is a need to do so, and now I'm going to talk to you more about the objectives of our project. Firstly, we're going to monitor the waste. We're going to be monitoring the waste management system, right? In the waste management currently, as I've told you, is extremely naive and doesn't encompass the large amount of variables that are there when we generate waste. It is a lot based on intuition and prediction. We're going to change that. Secondly, we're going to provide smart technology for a waste system. For a lot of time, people have thought that these things could never be incorporated with technology, and nobody actually tried. Hence, we're going to change that by providing smart technology with the bare amount of components that we have at our disposal, and change that. Thirdly, we're going to avoid human intervention. So by this we mean that humans have a lot of role to do in which areas like you should go and pick up garbage from, or where the trucks are scheduled, or where they allocate resources. We think humans are the best actors when it comes to resource allocation, and we think a technology in which we could feed parameters is a better judge of where things or resources can be or should be allocated, right? Fourthly, we're going to reduce human time and effort. So a lot of human time and effort goes into planning routes, or secondly, talking about where the waste is or how the garbage truck should be, and coordinating and planning either via calls, messages. We don't think that's an efficient way. We're going to reduce human intervention in that respect. Right? Fifth is, what is the end result of what we want? We want a society that is free of like diseases. That probably is a long-term goal, but we want to do our part in achieving it, which is to ensure that there is no garbage cluttering outside in public spaces. There is no city in which, or like that is a large-term goal also, but again there is no city in which garbage overflows and naive methods are used to pick up garbage. So let's move on and understand what the feasibility of our project. Alright, so let's look at the feasibility analysis of a project, right? There are four factors that we're going to talk to you about primarily when we talk to you about feasibility of a project. First is the financial aspect of this. That means the approximate cost for this project is 4,000 when we account for everything that we need to build the project, at least the very prototype. If we're going to scale it to a very large system, we need the cost of the system will be slight more, but I think the target audience that we're looking for who need to purchase this product should be more than capable of handling that cost for that system. Right, next we talk to you about the market of this product. This product will have a very niche market, and the very companies that we want to target are A, private garbage collection companies, or secondly, talk to you about more government organizations that should be invested. And I've already told you why cost can be a prohibitive factor for them to make sure that they never invest in these kind of technologies, so the market is taken care of. Third aspect is the technical aspect. We understand that some systems require a lot of servicing after they're implemented and installed. We don't think our system is one of those. We think our system can be seamlessly incorporated to the kind of and won't require any sort of technical checkups on a regular basis, and if any is required can be scheduled once every 6 to 7 months. That shouldn't be a big issue. The last idea of why this is the social narrative we're going to create is about the last idea, our device will solve a social issue and help us make a difference in society by methods of getting rid of garbage from various cities and areas. We think that is a big enough thing that we are willing, that we can do with our project, right? Let's talk about the scope. The scope of the project the scope of the project will encounter three areas. Firstly, the target market, where developing countries like India, where massive scale garbage systems are never implemented and large amounts of garbage is generated. China can also be one of the examples, because developing countries primarily are creating more garbage because they're hubs of manufacturing and import, and a lot of economic activities going on. That means the current garbage management systems are never capable of keeping up with the change that is happening around us. We think that those are the target markets. Secondly, no such product is implemented in USA. Heavy systems that rely on more technology or more advanced technology, where everybody has a personal device assistant, or where every truck is located with a GPS, is implemented, which I think is too harsh a cost to be borne by these developing countries. We don't think that system is feasible. Hence, our product is somewhat unique, which is extremely cheap and can help solve those issues. Thirdly, this is shifting the control of garbage collection from the whims and fancies of particular companies or human beings that were solely responsible for collection of garbage outside your house, to a more centralized system that is more unbiased in nature and is a better mechanism to deal with garbage around you. All right. So what are the functional requirements of a project? We need business. All right, so let's look at functional requirements for our project. We need business rules, we need transactions, corrections, adjustments and cancellations. We need administrative functions to ensure that we can add new bins that we can place at different locations. And secondly, that we can delete bins, or thirdly, modify routes and add trucks to our system as and when we require. The next thing we require is authentication, because we do not want anybody who shouldn't have access to our system to get into the system and modify the system. There needs to be some sort of security, and authentication will take care of that. Secondly, we need authorization levels, because a lower level worker should have the requirements, or shouldn't have the requirements that a top level manager or employee would have. That means that if a top level manager can determine the amount of bins that we need to service with one truck, the lower level manager or the lower level employee should only be able to access what bins he needs to service, rather than whether they need to service this bin at all or not. We think that is we should take into account. The next thing is audit tracking. We also need external interfaces, for example, people outside. That means if you want to spread this project to a large scale, we could have a tracking system where citizens could track whether the next pickup of the garbage outside their house, they could lodge complaints, but that is for a large level. The next thing we need is certification requirements, reporting requirements, historical data to ensure where garbage is most generated and where we need most amounts of garbage collection from. And we also need legal or regulatory requirements to ensure our system does not infringe upon somebody's rights or does not break any laws that are prevalent in any developing country. Non-functional requirements, let us look at certain things we're going to need. Firstly, we're going to need performance out of a system, because obviously a real-time system is heavily determined on the real-time performance of that system. Failing the system could lead to serious consequences. Secondly, we need scalability. Even though our project is limited to a certain amount of garbage bins, and this is just a prototype, but we need it to be scalable if we ever want to achieve the ends of a big corporation ever taking up this project. Then we need capacity for this project. We need availability, we need reliability, we need recoverability. In the off chance that this project ever fails, we need to ensure that there are certain recovering mechanisms to ensure that the project is functional again within no time, because a lot of people are dependent on this project and society as a whole would be dependent on this project. We need security that is provided by the authentication module. We need regularity, we need manageability, we need certain data would be sensitive and shouldn't be out there, and we need to protect that. We need usability and we need interoperability for our project. Here's the model of how we're going to implement our project, right? Let's look at this. So we're going to start at this location, and then we're going to check whether the dustbin is full or not. If yes, we'll send a message to the control room indicating that the dustbin is full and you need to pick it up right now. Then a cleaning vehicle will be sent to pick up for this very location, and then we'll update the status of the dustbin. This can be done if all amounts of garbage is taken out, the status will be shown as 0% full. If not, it will be shown as partially full, which indicates a percentage around it, and those things can be taken into account, right? So if it is not full, then what do? Then it sends out a negative signal to the control room saying the dustbin is not full, and we always repeat the system till the time we get a positive acknowledgement from the system. That is at the very basic level our model of implementing our project. Let's move on, right? So let's come to the part of the components that we're going to require to implement our project. We need 3 primary components. Firstly, a Raspberry Pi, which will be doing all the calculations and processes necessary for our project and for it to act as a proper embedded system. Secondly, we need LCD screens to display statuses at various points, and we also need infrared sensors to detect the levels of carbon. Alright, the first component that we'll be requiring is a Raspberry Pi. It's a standard model. Raspberry Pi 3rd generation. The seller is RS Components, that is the vendor. The price is the standard 3,000 rupees, and specifications are 1.2 GHz, 64-bit quad-core ARM-V8 CPU with 1 GB of RAM. Alright, this latest model of the Pi will incorporate a wireless module that is imperative for our project to ever link it with the GPS operation seamlessly, and that is something that we require, and that is why our choice for the hub or the main control system of our project is the Raspberry Pi. It's extremely essential. We also attached a reference URL where if you want to check out where to buy the Pi and how much does it cost. This is available on Amazon and it could be easily delivered within a couple of days to your preferred location. Okay, the next thing that we need for our project is infrared sensors. Infrared sensors, as you can see from the picture here, is that they can gauge the distance from the nearby object, and they have a multitude of applications when we come to employing them in projects. In our project particularly, this is going to be on the top of the garbage bin and can determine the proximity from the level of garbage, and that is how it determines. For example, if the garbage is up till here, then this distance is going to check this distance will be calculated, and that will be calculated to the total amount of space that is available in the bin to check how much garbage is collected. If it's here, then this distance is the primary distance. Owing to that, the component can work to gauge the level of garbage that we have in our can. Alright, so it's a common sensor that is available anywhere. The model number is RKI1196. The vendor is RoboKits India, and it's relatively cheap, only for 100 rupees. That is something that is affordable and can be used in various projects. It has a 10-12 centimeter range, so we're going to implement on a small scale. But if this project pans out, we're going to use a much powerful sensor for big levels of garbage cans. We think that this is a good starting point for a project, right? Here is where we have attached a link for a project. It's available on robokits.co.in. Do check it out if you want to buy this project, right? So it works on a 5 volt and 3.3 or 3.3 volt input as well. It is used for line sensing. That is something of an important feature of this project. Alright, the next thing that we need is an LCD module. Even though we'll try to do it without the LCD module by incorporating it through our screens, but for a larger scale, we do need the LCD component for every trash can and every bin. LCD module is relatively expensive. That comes with the Raspberry Pi. It is 2600 rupees, and the model number is PRD177. The vendor is ElkMech, and the specifications are it's a 3.2 resistive touchscreen display, and it is designed specifically to link with the Raspberry Pi. We think, and there's a reference URL here if you do want to check it out. And these are features that support the latest version of the Raspberry Pi, and the driver is provided. Hence, like, it can display same messages such as like full. If you go and see over here, with these dots, we can form our own patterns and like display full, FULL, or NF, which could determine not full, or half full, which is HF, or 0%, or anything that we want, we can do with this LCD module, and we can be creative when it comes to this, right? Okay, so list of softwares. List of softwares we need is firstly geolocation, that is in Python, which coincidentally happens to be something that was already there in the presentation and was there, right? So we need this application to ensure that we have given accuracy about a given location. This can be extremely useful when we talk about garbage bins that are placed all over the city and those are embedded in Google Maps. We need the absolute geolocation of each of them. More importantly, on the second level, we also need this geolocation for the trucks that are going to service these places, and that can be helpful as well. The next thing we need is IDLE 3, which is integrated development environment, which is linked with Python and can be a source on which we code the Raspberry Pi for various functions that we're going to do, and we think this is a software requirement that we use. Alright, let's come to the last segment of our presentation of the references that we chose for this project. Here are the list of references we chose for this project, and a lot of them have been talking about how garbage collection management are implemented in small cities. They're excellent papers that we use to gain inspiration from, and also some amount of like how we can implement our project in these locations. These are 10 reference papers that we have already attached in the report. Thank you all for seeing our presentation, and I hope you enjoyed it. Thank you and goodbye.